right, good morning, students. This one is about simple circuits, just going over the parts of a simple electrical circuit. This is probably something you learned a really long time ago. I know I remember learning about this when I was in elementary school. But we'll go into a little more depth. We'll add some more context to it. And what we're going to basically do is, as a way to kind of create an analogy, because electricity is a bit of an abstract thing. What it is. I know we learned that, it's the flow of electrons, electricity, it's electrons, but making an analogy helps us to understand the parts of a circuit and how electricity actually works. So for the analogy, we're going to be using a water pump. We're going to be using this kind of water pipe here. The water pipe goes up, it goes to the left, and then the water falls. It falls down by gravity and then comes back. There's also a water wheel here. So as the water flows by, the wheel turns. So we're going to use that analogy to understand, how all this works. So for instance, what in this diagram actually provides the pressure needed to force the water up? Well, that's pretty straightforward, right? It's the water pump. So the pump for an electrical circuit is the battery. It's the power source. So the battery provides what's called the voltage. So when we hear the word voltage, we want to think of like pressure. It's the pressure that's put into an electrical system that provides the energy, we could think of it as the pressure to move the electrons in the circuit. And it's measured in volts, which is a V. That's a symbol for voltage, is a V. So you can see here's a battery. We should also know that batteries have a positive and a negative terminal, right? And we've already learned about positive and negative, right? Negative means that there are more electrons over here. And positive means that negative means there are more electrons. Positive means there are fewer electrons. So we even know what direction it'll flow, right? Which we'll get into in a little bit. So here it is, positive terminal, less charge. The electrons flow into the positive and they flow out of the negative. So the negative terminal has more charge. The positive terminal has a little bit less charge. Again, it's positive. Positive actually means less. Negative means more. All right, so current, right? The current is the actual water flowing in the pipe. So it's your copper wire, right? It's the actual pathway that allows the electrons to flow. So electric current is the flow of the charge, and it's physically electrons moving through. You can think of like water moving through this solid, in this case, this solid object. We also learned that electrons can flow through liquids, through ionic fluids, fluids with ions in it. This is measured in amps or amperes. I believe that's named after a guy, Mr. Ampere, I want to say. I could probably look that up. Amps, A. It's measured in A, amps. Okay. So, electrons always flow from areas of more charge, so negative, to areas with less charge, positive. So more to less. All right, so last part here. Where the diagram do you think the water pressure is lowering because the water is hitting something? Well, that's pretty obvious. It's right here. It's the water wheel. As the water flows down by gravity, it's encountering a wheel. That wheel is stopping some of the water, so it's lowering the pressure. Okay, that's called resistance. And resistance is just the thing that electrons are encountering. It's an opposition to motion. It's opposing the motion. And that could be anything. It could be an appliance. It could be a machine. It could be, it could be anything. In this case of this fan here, like a computer fan, And the way any fan works, electricity flows through it. That allows the fan to operate, to spin. But the cost of having some electrons go into the fan and do something, the cost is a drop in voltage, a drop in pressure. So on one end of this circuit here, we have higher pressure, higher voltage. The electrons pass through. They do what they have to do. They're doing work, to make this fan move. But the consequence of that is that the voltage drops. Voltage is measured in ohms. I want to say also named after someone who worked with all this stuff. OHMS, and the symbol for ohms is the omega, Greek symbol omega, which is kind of cool. All right, so just some resistance relationships. Resistance generates heat. Yeah, it generates a lot of heat. When electricity passes through something, especially things with a lot of, wires or materials that are insulators, you have high resistance. And in the case of a incandescent light bulb, a light bulb right here, your kind of garden variety light bulb, the reason why it glows is because of the resistance. The electrons are being forced into this metal, this very thin metal, and now it's a metal, so that's a conductor. But here's what's very interesting. So yes, the metal wire inside of a bulb is it is a conductor, but the wire is extremely thin, so it has high resistance. So it actually glows. Copper wire is typically used in electrical circuits, all around your home, everywhere, because it has very low resistance, and typically does not get hot enough to cause a fire. So they're really now that doesn't mean that electricity can't cause fires. They absolutely can. It happens here and there. So conductors have low resistance. They allow things to flow very nicely. Insulators have high resistance. Thin wires have high resistance. A thick wire has low resistance. So, and last thing here, the fire hose analogy. Here's another analogy to help you understand electrical circuits. If you haven't noticed, water is used a lot to compare electricity. Water and electricity is just a good way to kind of put it together, because some of these concepts are a little weird. So the current is the water flowing through the pipe, flowing through this water pipe here and the hose. The voltage is the pressure. Okay, so when this is pushed down on, that creates pressure, and here's a pressure gauge. That's voltage. So the more we push down, the more pressure. Okay, resistance is this little valve here. So we can close this valve, we can open the valve. You can see here the valve is kind of closed a bit. So on the other side of the hose, we see lower voltage. But on the other side of the hose in the pipe, we see higher voltage. Again, this is something that's creating resistance. It could be anything. All right, so that's it for the lesson on circuits. There'll be a Google form to complete for this.